Thank you. And speaking about the work that we're going to do in the future, tonight we have with us an incredible speaker, Jamie Metzl, who's going to help us learn more about ethical implications in genetic engineering as he explores the delicate and fascinating world that not only lies ahead, but has already begun unfolding before us. So let's dive in. The Robert L. Biblo Lecture was established in 1995 in memory of a former Center for Practical Bioethics board member and a remarkable healthcare leader. And Jamie is taking up that mantle this evening. He's a technology futurist and geopolitical expert, novelist, entrepreneur, media commentator, and senior fellow at the Atlantic Council. In February of 2019, he was appointed to the World Health Organization's Expert Advisory Committee on developing global standards for the governance and oversight of the human genome editing. His passion in exploring the impact of genetic engineering, I'm certain, will nourish your dinner conversation and expand your appetite for all things genomic. His about-to-be-released book, Hacking Darwin, Genetic Engineering and the Future of Humanity, serves as our main course for this evening's remarks. We're delighted to have him back home in Kansas City. Please join me in welcoming Jamie Metzl.
Sean. Thank you so much to all of you. It's really such a pleasure for me to be back in my hometown of Kansas City. I see so many, actually I can't see right now because of the lights, but before, there's so many people in this room who've just played such an important role in my life, my being and becoming, from people who drove my carpool when I was a little kid, like Karen Pack, who is somewhere here, to people who were with me really at every stage of my life, Barbara and Don Potts, who were with me in the campaign years, and Quentin Lucas, who was a student at Washington University when he came to volunteer on my campaign here 15 years ago. And it's just thrilling. I'm going to talk about two more special people in a moment. It's just thrilling for me to be back in Kansas City and to be doing so in support of an organization as important as the Center for Practical Bioethics. We are in this crazy age when revolutionary technology is shaking the ground underneath us, challenging essential elements of what it means to be a human being. And we know the technology is powerful, but how we use this technology, that is the essence. That is going to determine what the world we live in is going to look like. And to have an organization as important, as disciplined, as focused as the center is really an asset for Kansas City. And one of the things about Kansas City is I think everybody here recognizes Kansas City is on the rise. I know when I was growing up, there was a little bit of Kansas City doom and gloom. That people would say, well, we're this city, we had a great, people would say, well, what's so great about Kansas City? And we would say the things that you say when you're not that proud of your city. Like, we have the second highest number of fountains in the world. It's like, who cares? But now there's an energy in Kansas City, and I think everybody feels it. Even in New York, when I first moved to New York 15 years ago, and I said I'm from Kansas City, it was like, oh God, you really made it a long way. It's like, yeah, I came with my overalls, I rode a mule. But now when you say you're from Kansas City, people say, wow, Kansas City, I've heard that things are really happening in Kansas City, and it's happening at so many different levels. So it's wonderful to be back. And it's particularly special to be back for me because, as I said, I grew up here. And because my parents, Marilyn and Kurt Metzl, are here. And my mother, just last week, I'm very proud to say, received the Lifetime Achievement Award from the American Psychological Association Division of Psychoanalysis in Philadelphia, which was just incredible. I think she deserved it. And my father, Kurt Metzl, who recently retired after being a pediatrician in town for 52 years. And when I was here in my campaign, I remember yes, he deserves it. in my campaign, I would go door to door, and I'd be just out in Sweet Springs or Lee Summit and knock on the door, and I'd say, "Hey, sorry to bother you. I'm Jamie Metzl." And they say, "Metzl, are you related to?" And so there were so many people whose lives were touched. But the reason why my father's family is here is that he and his parents came here as refugees after the war in 1948. And that side of the family, on my father's side, like so many other people, had just obviously a terrible experience during the Second World War and the Holocaust. And that certainly has been an important part of my being and becoming and my identity. And so it's ironic, in a way, that somebody who the whole reason this part of my family is in the United States was because technology was abused, because there was an ideology about selection of human beings based on certain criteria, that I'm here now talking about the genetics revolution and how that is going to transform our lives in such deep and fundamental ways, that it's going to force us to ask really essential questions about what does it mean to be a human being, about deeply personal issues, about disability and values, and that we're going to have to make some really difficult decisions. That some people will say, well, geez, that feels a little bit like eugenics. That feels a little bit like what some people call, quote unquote, playing God, because we have now these tools to influence biology. And if we had been in Germany in 1920s or 1930s, we could have come to a dinner like this, and people could have said, could have talked about, we have these incredible technologies, and we're going to use these technologies to do all of these wonderful things. And at that time, Germany was probably the most technologically advanced country in the world. And what went wrong? It wasn't the technology that went wrong. What went wrong was the values. That technology itself is agnostic. But if we use the wrong values, if we deploy the wrong values in determining how we're going to use our technology, these technologies that have the ability to do tremendous good can instead do tremendous harm. And that's why when we think about an organization like the Center for Practical Bioethics, when we think about the mission of bioethics, this isn't something like it's fun to talk about these issues, or you can have a bottle of wine and stay up late at night and have interesting debates on bioethics. What this is about is what value system are we going to bring to bear to figure out how to best use these technologies that have the capability and the potential to reorder all of life on Earth. Because that's the moment that we're in now. When Watson and Crick identified the double helix structure of DNA in the 1950s, what they were doing was essentially identifying that there is a book of life. And when the Human Genome Project came to fruition in 2003, what was made clear was the book of human life, the genome, could be read in the letters of A's, T's, C's, and G's. And now at the dawn of the age of gene editing, and I'm sure many of you have heard of CRISPR, but CRISPR is just one gene editing technology, and it will be very soon surpassed by many others that will be more precise. We are able to now write the code of life. So when we think about technology that's readable, that's writable, that's hackable, what do we think about? We think about our information technology. And we've internalized this message that our IT is variable, and that's why we just assume that every new phone we get or computer we get is going to be better and stronger and faster than the last one. But we have this illogical view that our biology is fixed. Because we just think that our kids are going to be kind of like us, and their kids are going to be kind of like them. Intellectually, we understand that 4 billion years ago we were single-cell organisms. Intellectually, we've only been Homo sapiens. Our ancestors have only been Homo sapiens for about 300,000 years. But yet somehow it's very hard for us to imagine
that our biology is a form of IT, which is what it is, that is readable, writable, and hackable. And we are developing the tools that will allow us to do that. And those tools are going to transform our lives and our transforming our lives in a process that is moving extremely quickly. And it's already showing up, but people are seeing it in bits and pieces and aren't pulling the full story together. So it seems like science fiction, but this isn't science fiction. This is, in many ways, science fact. And so what are the ways it's showing up? First is in our healthcare. I had a wonderful time this morning speaking to 800 students, incredible students at Kansas City University. And what I was telling them is that the healthcare world, the medical world, and beyond is going to be at the pointy edge of the spear of this revolution, because we are moving from our current system of generalized healthcare based on population averages, whereas in most cases, if you have, say, a cancer, you're given a best guess medication by your doctor, and it may help you, it may do nothing, and it may kill you. And the way you find out is if it does one of those things, and if it doesn't help you, then you try again, and maybe the new thing will kill you, and maybe the third thing will kill you. But we're moving towards a new model of precision medicine, which is based on each person's individualized biology. You may have heard of gene therapies, these treatments where you take cells out of a body and of an individual's body, manipulate them, and put them back with new powers, like with CAR T cells, superpowers to fight cancers. You may have heard of different treatments for all kinds of things, like precision pharmacology, where you understand a person's genetics and are able to make predictions about what type of drugs would be more suitable for that person. And as we move from this world of generalized medicine based on population averages to precision medicine based on each person's individual biology, we're going to need to get a lot of information about people. And that's why we're going to see and are increasingly seeing a revolution in population-level genome sequencing. So right now, in 2003, at the end of the Human Genome Project, it cost about $1 billion to sequence the first human genome. Right now, it costs about $800 for whole genome sequencing. And within a decade, it will be less than $100. And as a matter of fact, it will be free in most cases, because the benefits to society of mass sequencing will outweigh the costs. And so what's that going to mean? So we're going to have millions, and then within a decade, probably about 2 billion people will have their whole genome sequenced. Because we're moving into this world of precision medicine, this sequenced genome will be the foundation of people's electronic health records, because that's the way you're going to be able to match up a person's biology to their treatment. We're going to have these massive data pools of genotypic gene information and phenotypic information, which is how those genes are expressed over the course of people's lives in health and beyond. And then we will have big data analytics to put those pieces together to derive insights. And those insights are going to be way beyond the capacity of the individual human brain. I mean, this is way beyond what we can do, but humans and human biology will move increasingly from what we used to see and understand as indiscernible magic to a data set that can be increasingly understood. It's a long way to have complete understanding, but our understanding of our complex biology will grow, because our biology is about as complex as it's been for millions of years. But the sophistication of our tools is increasing at an exponential J-curve. And so there will come a time when the relative complexity of our biology is mostly understandable through the medium of our technology. And what will that do? First, it will move us from the world we're in now, where the most actionable genetic information is about single gene mutations, the so-called Mendelian disorders and diseases which are caused by a single mutation, kind of like an on-off switch. And you're familiar with these, like Tay-Sachs or sickle cell disease or Huntington's disease. But we're going to know more about complex genetic diseases and disorders that are influenced by hundreds or thousands of genes. But because it's not a binary yes or no like it is for these simple disorders, we are then going to move into a world of probabilities and predictions. And that's the second transition of healthcare, from precision to predictive. And the predictive won't just be that you are having a symptom of a disease, and then you go and you have your sequenced genome, or you sequence your tumor, and we can understand a more complex genetic disorder than we can today. We're going to have information that will be known to you or to your parents, perhaps a few days after conception, most likely at birth. So think about that. You are born, and you're at the hospital, and your parents are getting their final conversation, their final interview with the doctor. And the doctor says, you know all the things, and here's what you need to know about breastfeeding and changing your diapers, and here's the emergency phone line you can call. And by the way, just FYI, your child has a 40% greater than average probability of getting early onset familial Alzheimer's or Parkinson's. If you said that to somebody now, they would say, I think WTF is the thing. Like, why are you telling me this? But that's going to change, because we're going to think about predictive medicine as giving us an opportunity to intervene in ways that can enhance our opportunity to live a long and healthy life. But we're going to need to have that information. But that's the least of it, because the second transformation that we're going to have is that genetic information, as we all know, isn't just about healthcare. It's not just about disease. Genetics is about genetics. It's about the stuff of life, of who and what we are. So in addition to having this information about future health states, we're going to have lots of information about all genetic traits. And what are genetic traits? Well, just look around this room. Everybody looks different. Why? Genetics. Everybody has different personalities. Why? Genetics. Dare I say, people in this room are all super high IQ, but I imagine there are some differences. Why? Mostly genetics. And when we talk about these deeply personal human traits, it gets very uncomfortable for us, because we like to believe, because we're all progressives, that everybody is born kind of exactly alike. But we know that it's not true. And as we understand more and more of biology, we're going to be faced with this knowledge. And there will be some societies where people are going to want to know that I have a kid who's got a great genetic potential to succeed and excel in abstract math or sprinting or have an outgoing personality. All of these things that we can't understand now, but we will through a process called polygenic scoring, which allows us to think about complex genetic traits that are influenced by many thousands of genes and make predictions that aren't 100% accurate, and not every trait is entirely genetic. As a matter of fact, most traits aren't. But we will be able to predict probabilities of outcomes. And this will move genetic information outside of the entire realm of healthcare. Many of you have done your cheek swabs with 23andMe, and you get information about your ancestry. That's not healthcare information, that's just life information. And sometimes you get other information, whether you may like the taste of cilantro or not. That has nothing to do with healthcare. We're going to get a lot of information, and a lot of information that is going to look under the hood of who and what we are, of who and what our children are, of what capacity our children may have. And certainly we don't want to live in a world of genetic predetermination. But also, I think for many people who are parents, it's like identifying that my kid had a special capacity to be great at violin or something. That could be relevant information, and some people will want it. And so we're going to have all of this information outside of the realm of healthcare. And then the third area, maybe the killer, quote unquote, killer app for this technology, is going to be in reproduction. Because relatively quickly, I believe we are going to move into a world where more and more parents are going to want to conceive their children outside of the body, to do it in the lab. We already have in vitro fertilization, a process called pre-implantation genetic testing, which is essentially sequencing roughly 5-day-old embryos prior to implantation in the mother. But with all of the information that we can now garner from sequenced genomes, we're going to be able to have all of these kinds of this knowledge and information that I've mentioned before for pre-implanted embryos. And so mothers in places where this is legal, who want to do this, will be able to say, tell me more about these 15 embryos and their likelihood to live healthy, long lives. Rank them, which is almost possible today. Rank these 15 embryos tallest to shortest. Rank these 15 embryos in order from highest potential genetic IQ to lowest. And then we have new technology, again, already exists, hasn't yet been used in humans, to break the logjam of human egg production by using adult cells, inducing them into stem cells. So you take a skin graft, induce those cells, it could be millions of cells, into stem cells, into egg progenitor cells, into eggs. Now you have 10,000 eggs. You fertilize 10,000 eggs with male sperm. You grow them to 5 days. You sequence all of them because, as I mentioned, the cost of sequencing is zero, and this is all done in high throughput machines. And then you have a lot of options. And then you can really, and I have an editorial in the New York Times in this Sunday's paper on this, then you can say, all right, well, what are your priorities as a parent? What are you looking for? What are you thinking about? And I can see, at least in the front of the room, I can see the uncomfort. I can see it in your body language, and you're right to feel it. Because I haven't even mentioned gene editing. And then on top of that, we can use these new technologies, better than CRISPR, to make a relatively small number of gene edits, like was done unsuccessfully but tried in China last year, to either eliminate some kind of threat or confer some kind of genetic advantage. And all of this is coming. And all of this is coming fast. As a matter of fact, it's coming so much faster than most of us appreciate. And we live in diverse communities where societies are different within and societies are different without. I mean, I was not at all surprised. As a matter of fact, my book, Hacking Darwin, was already in production when it was announced that the 2 Chinese babies were born last October who had been genetically engineered. And so I had to fight with my wonderful publisher, and I pulled it back out of production, but I only had to add a couple of paragraphs because in the book, I had said, this is going to happen, it's going to happen in China, and here's why. And the reason it was going to happen in China, because it's a different regulatory environment there. So we have these differences. But we also live in a world with a tremendous amount of competition. And when there are advantages to be conferred, particularly for people's children, people will go to great lengths to get those advantages for their kids. And we see many examples of this, both on the individual and on the societal level. But there are, as you may have guessed, fundamental, and this comes back to our theme of why we're here, ethical issues. The issues of equity. Who has access? Let's just assume that it's safe, and let's assume it's beneficial. Who has access? And how do we think about issues of access? Diversity. We all have all of these ideas of what we may want that makes sense in this environment. But there's no such thing as evolutionary fitness or lack of fitness in some absolute sense. Evolution exists within the context of now. So some traits that seem not valuable now could be extremely valuable in the future. But if parents or societies are making big decisions based on what the world looks like today, that could be threatening to us on an individual level. It could dehumanize us, but it could also threaten us as a species. And because the technologies are new, but the values we're going to need to use them wisely are old, we need organizations like the Center. We need to all feel that we are part of this conversation about what is happening. So on an individual level, and that's one of the reasons why I'm so happy to speak to all of you, everybody has to get smart. Everybody has to understand what's at stake, because this is not some abstract issue. This is about your lives, your healthcare, your future, your children, and the world that they are going to inhabit. And that's all of our business. And we all know that in some ideal world, maybe it's Singapore, we can just sit back and say, well, the government is going to handle this. But the government isn't going to handle this. Government is not handling this. And so we all need to be part of the process. We all need to speak to our elected representatives. We all need to make sure that regulations, and we need regulations, that we have great regulations where we are. But we're all stakeholders also in making sure that there are great regulations in other countries, in other places. And one of the reasons why I'm so honored to serve on the World Health Organization committee that John said is that this is a global issue. And so we as a species are going to need to find a way to come together to try to figure out what are the rules of the road for how we use these technologies. What are the guardrails? What are the red lines beyond which we shouldn't go? I don't have any answers to these questions, but what I can say is my one answer is we all need to be part of the process. We all need to roll up our sleeves and engage. You're all going to get, thanks to the Center and thanks to the incredible work that Vivian and Roger from Rainy Day Books have done. I think you'll meet them in the back. You're all going to get a copy of the book at the end. And in the book, it's designed to be a foundation for conversations that you can have. You are all a little center for practical bioethics now. And I have 9 questions at the end of the book that you can use at your dinner table, at your church, at your synagogue, in your book club, because this is not just interesting, this is life. Thank you very much. Thank you.